Once again, welcome to EmmanuelSTEMAcademy. Today, we shall be looking at organic chemistry. Organic chemistry is a major aspect of chemistry. Chemistry as a subject is divided into two broad aspects. We have the inorganic chemistry and the organic chemistry. So today, I'll be focusing on organic chemistry. I will start from the very beginning, which is the alkanes. And we shall be looking at the homologous series and the functional group. First of all, what is organic chemistry? Organic chemistry is the chemistry of carbon and its compound. It's the chemistry of carbon and its compound. All the compounds of carbon are organic, except the oxide of carbon and the triiodocarbonate 4 compound. Carbon have two oxides. We have the carbon 2 oxide and the carbon 4 oxide. And the carbon 4 oxide. These oxides of carbon are inorganic, and all triiodocarbonate 4 compounds are inorganic. For example, sodium triiodocarbonate 4 is an inorganic compound. For example, magnesium triiodocarbonate 4 is an inorganic compound. So it means that all triiodocarbonate 4 compounds and the oxide of carbon are inorganic, but every other compound of carbon are organic. Organic chemistry, the reason why carbon, I will just throw no light on the reason why carbon is the most abundant element in the study of organic chemistry, and the reason why carbon is very unique in organic chemistry is that, one, carbon as an element exhibits allotropy. Allotropy is the ability of an element to exist in more than one form in the same physical state. So carbon exhibits allotropy. If you have a topic, if you have been taught the topic carbon and its compound, then they will tell you that carbon exists as diamond and carbon exists as graphite. Those are the crystalline forms of carbon. So in a crystalline form, carbon can exist as diamond and graphite. That phenomenon is called allotropy. We have the amorphous form of carbon too, and in the amorphous form, carbon can exist as coke, carbon can exist as charcoal, carbon can exist as soot, carbon can exist even in the charcoal form. Carbon can exist as wood charcoal, animal charcoal, sugar charcoal. So the ability of carbon to exist in more than one form in the same physical state is called allotropy. So allotropy is one of the reasons why carbon is more abundant in the study of organic chemistry, or why carbon is so unique in the study of organic chemistry. Number two, carbon exhibits catenation. And catenation is the ability of a compound to have more than one bond between its atoms. Two carbon atoms can have more than one bond. They can have single covalent bond, they can have double covalent bond, and they can have triple covalent bond. This phenomenon is called catenation. So carbon atom catenate, and so this is the reason why compounds of carbon are very numerous. Why carbon is unique in the study of organic chemistry is that carbon exhibits hybridization. That is, the atom within carbon can blend into different shapes. Later you understand when I will tell you that the alkanes are sp3 hybridized. The alkene are sp2, that is double covalent bond, are sp2 hybridized, and triple covalent bond are sp hybridized. That hybridization is one of the reasons why carbon is so unique in the study of organic chemistry. Another one is that carbon exhibits isomerism. Isomerism is the ability of the atom within carbon to rearrange themselves in more than one form. That means the atom within a carbon atom can reset themselves within that same molecule. That phenomenon is called isomerism. As time goes on, I will carry out the practical for you. You see how isomerism works. We have positional isomerism, we have structural isomerism, we have geometrical isomerism. We will discuss them one after the other. But for today, let us focus on the alkanes. What is the alkanes? First of all, before I introduce the alkanes, I would like to talk about the homologous series and functional group. What is the homologous series? The homologous series is a family of organic compounds. The homologous series is a family of organic compounds. So that means, just like you say family, in organic chemistry, another term for family is homologous series. So the homologous series is a family of organic compound which follows a regular structural pattern. For instance, members of a family, in a nuclear family, for instance, they are believed to be related by blood. Yes, that is why we said in homologous series, they follows a regular structural pattern. So the homologous series is a family of organic compound which follows a regular structural pattern by being conformed to a general molecular formula. By being conformed to a general molecular formula. And each successive member of the series differs by a CH2 group. And each successive member of the series differs by a CH2 group. So therefore, a homologous series is a family of organic compounds which follows a regular structural pattern by being conformed to a general molecular formula in which each successive member of the series differs by a CH2 group. Once again, a homologous series is a family of organic compounds which follows a regular structural pattern by being conformed to a general molecular formula in which each successive member of the series differs by a CH2 group. What is a functional group? A functional group is a heteroatom. Don't worry, later I'll come back to in my next video. I'll explain why I say a functional group is a heteroatom. Because we have hydrocarbons and heteroatoms, which I will differentiate in my next lesson. But please do wait to subscribe to my YouTube channel. That is EmmanuelSTEMAcademy. Do wait to subscribe to my YouTube channel because there you see more of my videos. Like I say in my next video, I'll be explaining differentiating between hydrocarbons and heteroatoms. By subscribing, you always get a notification. Turn on the notification bell so that each time I drop my video, you'll see it. Thank you so much. So let's go. So a functional group, like I say, is a heteroatom. Heteroatom. It's a heteroatom. It's a heteroatom. Common to a particular homologous series, which determine the chemical property of that series. So what the functional group does particularly is that it determines the chemical property of a particular homologous series. So no homologous series has a chemical property unless being conformed to a particular functional group. So this definition is very, very important because it will help us to understand this organic chemistry as time goes on. So let's come to the alkanes now. What are the alkanes? The alkane is a homologous series. That is so that it is a member of a family. So the alkane is one of the homologous series. So I can just say the alkane is the homologous series which has a general molecular formula CnH2n plus 2. This is the general molecular formula of the alkanes. Every member of the alkanes comes from this general molecular formula. You can get the first member of the alkanes from here. And for the first member of the alkane, N is equal to 1. And that member is C1H2 times 1 plus 2. And it's CH, 2 times 1 is 2 plus 2 is 4. And it's CH4. So CH4 is the least and is the first member of the alkanes. The next member of the alkanes correspond to N equal to 2. And is C2H2 times 2 plus 2. And that is C2H, 2 times 2 is 4 plus 2 is 6. This is the second member of the alkanes. Using this general molecular formula, you get more members of the alkane, which is C3H8, which is C4H10, which is C5H12. These are the members of the alkane. So let's use this to explain the homologous series and the functional group first. Now, like I said, the first member of the alkane is CH4. Second member is C2H6. Third member is C3H8. What is the difference between these two now? C2 minus C1 is still C. H6 minus 4 is 2. Same thing here. C3 minus C2 is still C. H8 minus 6 is 2. Correct. So this explains homologous series. So because I said the homologous series is a family of organic compound like the alkanes, which is conformed to a general molecular formula CnH2n plus 2 in the case of the alkanes, in which each successive member, each successive member differs by what? A CH2 group. So this really explains what I call the homologous series. The alkanes, like the early members of the alkanes, are gases. The alkanes are gases. So methane is a gas. And don't forget that methane, of course, which is the first member of the alkane. Don't forget, in my next class, I have other classes where I will give you the higher part nomenclature of the alkane. Then you get to know why this CH4 is called methane. This one is called ethane. This one is called propane. We have butane, pentane. There are so many members. There are over 1 million members of the alkanes. In another class, we'll do that. But for today, let me explain something to you. Now, methane is a gas, and of course, methane is a major constituent of natural gas, about 95% natural gas. So it will remain a gas, but when conformed to a particular functional group, methane, for instance, if methane is attached to OH minus, don't forget OH minus is the functional group and it's called the hydroxyl group. So methane as it is now is virtually insoluble in water. Methane does not mix with water. But then when attached to hydroxyl group, it becomes CH3OH. I also explained to you in our last class how this is possible. And this is called methanol. Methanol is soluble in water. Methanol is soluble in water. So you can see that the functional group, the hydroxyl group, have been able to change the chemical property of methane from being virtually insoluble in water to being soluble in water in the form of methanol. This is the primary reason for today's class. I define the homologous series, I define the functional group, give you a practical example of a functional group. I will have other example. We have the oxalic ion, we have chloro, we have fluoro, bromo. There are so many functional groups which we will discuss as time goes on. So please, like I said before, do what to subscribe to EmmanuelSTEMAcademy. Subscribe to EmmanuelSTEMAcademy. Also invite your colleagues, your friends who are also in secondary school or who are having challenges with organic chemistry. I will drop so many videos on organic chemistry from the beginning to the very end for you to understand the iopag nomenclature, those areas that are having challenges. I believe that as time goes on, if you continue to follow my YouTube channel, organic chemistry will be well simplified to a level where you can even close your eyes and pass your exam. Thank you.